Hi everyone, welcome to another video. Uh, we have seen so far how to communicate with a local server. Right now we will see how we can benefit from a cloud resource. Specifically here I'm going to elaborate on Compute Canada high performance clusters. Alright, these are the topics that I'm going to elaborate on: dedicated server versus shared resource architecture, and also a resource management tool, and other topics about how to submit a job, how to run your, or quote unquote, how to run your application on a server. So we have so far we have seen the left case scenario, which was the local server that I had in the University of Lethbridge, and also I am sharing that with a couple of other grad students of my supervisor. So this server is pretty much dedicated to us. And when I get access to the server, when I SSH to the server by using Git bash or mobile extern, I will get access to the exact machine that we have, and the exact machine on which we have GPUs. And the way that we can manage our resource, the way that me and other grad students of my supervisor, we manage the server, and also we share the resource between each other, is like I call my buddy and ask, hey buddy, I'm going to run my job, please don't submit any job for like two days, or yeah, we are handling that manually, and we don't have any software for managing the resource. And it is not necessary for us to have any tool for managing the resource. But on the other hand, on the right side is Compute Canada. When I get access to Compute Canada, again in the same way by using SSH, I don't get access to a dedicated cluster. It's not like Compute Canada has bought a couple of $1 million computer and they have dedicated that to me, and while I don't have to run a job for that on that server continuously, and I am not even supposed to continuously use that server. So it's not like that they buy a couple of $1 million server and they give access to me, and they dedicate that server to me and say that, Reza, don't worry about that, we have spent a lot of money on that, but you're fine. Whenever you want to use that, you can use that, and whenever you are not using that, we will leave that server alone. So it is not the case here. They have a head node which everyone has to connect to that, and then you submit your job. For instance, in the previous video we had my python.py. It was my project.py. So it was my job, and I could directly run this command: python my project.py, and then I could press enter, and it will run the job exactly, run this project exactly on this server. But it is not the case here. On the right side, you have to uh, talk to the head node and ask him and describe the resources that your project needs, and then submit your job. And then the manager that we have here, the resource manager that we have here, it is called SLURM. SLURM stands for Simple Linux Utility for Resource Management. So in our previous scenario, we were a couple of students using the same server. We didn't need a sophisticated resource manager, but we do need that on Compute Canada or any uh, high performance cluster that it is shared between researchers. In this case, all the researchers, most of the researchers in the Canadian universities. Alright, so the takeaway from this part is that you don't have a direct and dedicated server, and you have to talk to the head node and you should not directly run Python my project when you get into the head node, because the head node is just an interface. It doesn't have any functionality, and if you run this, first of all, you're not allowed to run directly your project. I don't know what would be the ramification of that. This second of all, if even if you run that, uh, if you run it, for instance, simple project like printing a hello world, it will take like 10 times more time, because this head node, it is not supposed to run anything, so it doesn't have high resources, it doesn't have high GPU, high uh, it, it doesn't even have any GPU. It has a very limited CPU for just receiving the description of your project and then that into the queue. Put that into the SLURM queue. All right, let's go back here. We covered the first important point here, which was the architecture, and then we talked briefly about the resource management. Let's go and connect to the Compute Canada, definitely by using MobaXterm and not torturing ourselves with using Git bash. All right, so let me connect to which one? To Cedar. Again, it asks me to enter the password and then two-factor authentication process. All right, now we should be fine. I use my application. It's not a uh, Google Authenticator app or Microsoft Authenticator. They have their own software for two-factor authentication. Anyways, we have connected to the head node of the Cedar cluster. Let's go and navigate to my own folder. In our group, in the group of my supervisor, there are a couple of other students. So I need to first go to my own folder. It takes a bit longer time than the local server that we had, because as I described, this head node has a very limited functionality and it has a very uh, low CPU, so it takes a little bit more time to interact with. Right, so I have a test folder here, and I will go ahead and um, run a simple job on the server. So the simple code that I have here, it's a Python code that will run this code. It will sleep for 5 seconds at first, and then it will create a file called hello world.txt, and it will print the hello world 4 times in that file, and then finally it prints the file created successfully. Alright, so let's go ahead and submit this, run this code on the server. So previously in our local server, we could simply run Python simple code. Oops, we are not in that folder. So let's navigate to this folder first. So previously we could simply run Python simple code.py, but you're not allowed to run that here, and I don't think even they have the Python modules already available. So let's just try that. I don't remember what was the result of running a code directly here. File created successfully. Okay. In this case, that we had a very light program, it allowed us and it ran the file, but it is not recommended to do such a thing, because uh, you can down the whole head node if you run a very demanding job directly. So let's clear the output, the txt file, and submit our bash script and upload our bash script. Run job simple.sh, which is my bash script. In this bash script, I have couple of lines that is going to describe my project and its requirements to the SLURM, to the resource manager, and also at the end of the file we have. Let me see why hello world cannot get deleted. Remove hello world ls. Okay, great. All right. So the third thing is the running a simple job. For running a simple job, first you have to submit that. Here, simple job. This is my bash script. The first line is telling the Linux, the operating system that is going to run this file, that the content of this file should be interpreted as bash. And the other lines are flags for SLR. So right now I'm describing the time it takes 0 day and 0 hours and 0 minutes and 40 seconds. That job is so light that we have here simple code. It should probably take not more than 6 seconds. So that's why I have a 40 seconds time limit for that file. And you have to have a close estimation. If you just simply type 1 hour here, the resource manager will give a lower priority to your file and it will take longer time to run so that the resource manager can get into your file and allocate resource to that, and also finally run and finish the job. And the second thing is memory. We need like 1 gigabyte memory RAM. Other than that, we don't have any other requirement. It's a simple job. We don't need GPU. We don't need different nodes. And the other flags are for getting notified whether the job has started or has finished or has got a timeout limit or it just failed. So for this, in order to get these messages, I have passed my email address so that I can be notified about beginning, end, and also if the job has failed. Other flags that we have here is output and the job name. Here is the job name, simple job, and the output of your program. Any print statement that you have, it will go into your output file. In this case, I have the same name for my log files. So if I change that, my output will go to simplejob.output.log, and my errors, if I get any, it will go to simplejoberrors.log. And the other lines is my job name. I haven't used this variable anywhere in my code, but yeah, so we can remove that. And then I need to load the environment, the standard environment, and also the Python version that I need to use. and then finally run my Python uh, code with this line, this command, python simple code.py. So when you, let's save that and uh, send that on the server. So right now we have the bash script, the run job bash script. The next step is introducing this bash script or passing this bash script to SLURM. sbatch is the command for doing that. Sbatch run job simple, or it should, I should have written run simple job, but anyways, press enter, and then we will get a note. It submitted successfully, as you can see here, and also we have the job ID for that. But we also got a note. It's not a warning or error or anything, it's just a note. So your memory request of 24 megabyte was likely submitted as 1 gigabyte. Please note that SLURM interprets memory request denominated in G as a multiple of 10, 1024 megabyte, not 1000 megabytes. So right now I have submitted the job. The way that we can get the information of this job that we just submitted is by using sq-job. I don't remember it was -job or -j, so let me just get the use -help. Yeah, so it was -j. So sq-j and the job ID that we got after submitting that. Paste and then press enter. So it shows you some information about the job ID and the user. My username is Reza, and the account of the account name of our group, the name of my job, the situation of the state of that, which is pending, time left 1 minute. It rounded up the time that we specified here. It was 40 seconds, but it rounded up to 1 minute, and the whole 1 minute is remained because we simply hasn't started the job yet. It is pending. The number of nodes that we are going to acquire for running this job is 1 node, CPU 1 CPU, and we don't have any GPU. We don't need that. We don't need any GPU for that. And also the minimum memory 1G, and the reason that our job is still pending is priority. So it has got into the priority list, and it is waiting for the nodes to get free and start its process. So we have to wait, and also or we can also check our email to see if we have got the start notification. So another way that you can get the information of your job, if you don't remember the job ID, don't panic. You have another way. You can use sq pipe grep Reza1, your username. So it will go through all of the when you run sq, it will print all the jobs on the server on the specific node that you have connected to. In this case, cedar5, node cedar5. So if we run sq, it will show us all the submitted jobs. You see, we are not the only person who's trying to use Compute Canada. So that's the reason that they are not dedicated. They are shared between these many people that they are trying to use that. All right, so let's clear that SQ. When you use SQ, you will get that output, and we grep all the lines that contain Reza1, which is my username. Reza1, the one and the only one. All right, we got the info again, and also we got an email for, I just received an email for the job that we submitted. So our job ID named simple job began, and the queue time was 5 minutes. It was in the queue for 5 minutes. Strange. And the job only takes 7 seconds and completed successfully with exit code 0. So let's go and refresh to see if we got the output. Yeah, we got 2 files. The log file, it contains our print statement, and also our job had txt file. So this was a simple job that you could submit. We can also have a full-fledged Python code. So let me just use my own Python code that I had for my own thesis, and then run it. So let's take a look at it. Take a look into the run bash script that I have for running my own Python code, which requires GPU and also many other things. So the first line is as before, the first 2 lines. In the second line, we are telling the resource manager that we only need one node for running our job, but on that node we need a node that has at least, or no, not at least, exactly at least 2 free GPUs, because we are going to use 2 GPU. And task per node, I forgot what was exactly the task per node. Request 1 process per GPU. Okay, so when you run your job, you can have multiple tasks, especially if you're running multiple processes, which is the case here, because I have one Python code that will be executed for 2 times, and each of those processes are going to train a network and also communicate with each other along the way. So I am going to use a parallel computing here, and that is the reason that I'm going to ask for at least 2 tasks in this node, because I'm going to run the Python code that I have here, the April 18 train.py, 2 times in 2 different tasks, and they are going to be run in parallel and also communicate with each other to train the network in parallel. And also CPU per task, the number of CPU cores that you need to ask for your task. These CPU per tasks come in handy if you are, for instance, loading your dataset. If you get more CPU per task, your dataset will be fetched from the HDD, or SSD, the disk, very fast. But if you get a lower CPU per task, for instance 1, it's significantly affect the processes that needs more CPU. So I will get 4 CPU per task, and also I need 135 gigabyte RAM for my uh, program, and this RAM will be divided between all the tasks that you are acquiring. So each of them will get all of your tasks accumulatedly can use 135 gigabytes of the node. If you get into using more memory, RAM memory than what you have written here, your job will simply fail. We have discussed the other lines before, and one more thing, guys. If you type down here more time than what is actually required for running your job, or more GPU, or more RAM, memory RAM, or more GPU, your job will be executed uh, very late, and it will get a very low priority. Why? Because it is using up so much resource. So try to have a close estimation to what you actually need to use. But for the CPU, I don't think that it will come into the calculation to calculate your priority. And if you want to know more about the queue time and how your SLARM how SLARM is queuing your job and how it is prioritizing your job over the other jobs that we saw. Do you remember when we ran SQ, we saw a lot of people that have submitted a lot of jobs? So if you want to know how you can get more priority than other people, you can Google about fair share algorithm or fair share level algorithm. This is the way that SLURM is working on is prioritizing jobs on Compute Canada. Anyways, let's go and submit our jobs. Okay, we didn't discuss the rest of the thing here. So I have a variable here for my job name, so that I can simply, whenever I'm using this bash script, I can simply come here and edit this job name, and later I'm passing this job name as an argument to my April 18 train.py file. So, and the other things is loading the standard environment and the CUDA version that you need to use, Python version, and also activating your virtual environment. I will probably write about the details of activating the virtual environment and other details that you need to know on my webpage, but here we only stick to the big picture. And also here we need to get the IP address of the node that we have acquired. So you remember I here explained that I am going to use 2 GPUs and also 2 tasks. So each of my tasks that are running on this node, they need to know the IP address of the server so that they can communicate with each other. So that's the reason I am passing this IP address to I'm exporting that IP address to a variable, and also echoing the IP address in my file so that I can be aware of the details. And later I will get into the running of the Python file. This srun, as it is mentioned here, will run the Python file, this line, 2 times, or by the number of the GPU cores that you have acquired. So in this case I have 2 GPU cores, it will run that 2 times. And each of these processes will continue training and communicate with each other with a method that I will describe later in the parallel computation. And these are all the other arguments that I am passing to my own Python file. It has nothing to do with the resource manager. Resource manager was done here with these SPatch tags and also all other flags that we have used here, this time flag, node flag. We have described the requirements and the um, resources that our job needs for in order to complete this task. But here I'm passing the uh, arguments that my own Python file needs for completing this task, and it has nothing to do with the resource manager. For instance, I'm passing batch size or job name or learning rate or other arguments that I have here. All right, so let's submit this sbatch run.sh. We have submitted that. Let's submit that another time. Run job.sh and sq grep reza1. All right, unlike our previous job that it didn't have any GPU, here we have 2 GPUs. And overall, we have 8 CPU cores. Why? Because we mentioned here we need 4 CPU per task, and we have 2 tasks here. Task per node, we have 1 node, we have 2 tasks per our 1 node, and we have 4 CPUs per task, each of which will take 25 minutes. That's why we have 25 minutes here. And also they are both pending, and yeah, so, and the reason is none, which means that the resource manager hasn't got into calculating the fair share level of your job that you submitted here, this very sophisticated job. It is still calculating that. Once it's calculated, it will decide whether it is priority or it shouldn't be it shouldn't get into the priority list or any other reason that they will describe here. So let me just cancel both of these jobs here. Cancel. If you cancel, you will get notified, like here. Let's cancel. So let's double check that we have canceled everything and we don't have any unnecessary job, so that we don't waste any resource on this cluster. So it finished it. This command sq grep reza1, it returned nothing, which means we don't have any job submitted, and we got 2 cancellation, cancelled. So we canceled both of them successfully. Guys, that's the big picture and the most important things that you need to know for using Compute Canada or any other cloud resource. I hope you got something out of that. If you did, please share it with your friends, and also leave a comment and like, and see you next time. Take care.